In this video, we'll talk about the detailed architecture of how the Retrieval Augmented Generation or RAG works. So there are two phases of RAG. One is the ingestion phase and the other is the runtime phase. The ingestion phase is a one-time activity where we take the PDF or the text or whatever we want to kind of power the RAG application with in the form of vector embeddings and store them. This is a one-time activity which is ingestion. Runtime is when the user makes a query or tries to interact with the system, correct? So let's first look at the ingestion phase. In the ingestion phase, we are saying that there is an agree expert who prepares a PDF or has a text document which is converted into chunks or small pieces, and these chunks are converted into embeddings using an embedding model, and these embeddings are stored in a vector database. So the purpose of this activity is to make sure that we have the data which is an input data converted into vector embeddings and stored in the vector database, so that anybody who makes a search in the future is the searches of any user which come in the future are again compared against those vector embeddings using cosine similarity. Okay. Now the reason why we do the embeddings and store in the vector database as compared to storing the text is that the semantic meaning of this words in a given sentence is retained, and that is the benefit or advantage of using search using cosine similarity, because what we ask in English in the form of NLP is easily represented and the closest matches are found using this approach. Now if you have a user and at runtime, now let's look at runtime. The user makes a query and the query is again converted into vector embeddings, and those embeddings are compared using cosine similarity against the original vector database, and the vector database then returns the chunks corresponding to those particular vectors which are similar, and whatever chunks they correspond to, if you see here the second box, chunks, whatever chunks they correspond to, those chunks are returned, and those chunks along with the user query, if you see here the original user query, which means what is the fertilizer which needs to be applied during flowering stage, if that is a query, that particular query and the chunks which are cosine similar to the user query based on the vector embeddings of the user, those chunks and the user query goes to the LLM, and the LLM says, hey, I have a user query which says what is the best fertilizer to apply, and I have some 5 chunks and each chunk gives me different information, but all of them are somewhat similar to the user's query, which is what fertilizer should I apply in flowering stage, correct? Now using these chunks and using the user's query, the LLM responds, and that response is given to the user. Now the role that the LLM plays in this entire equation is that it takes the chunks, it takes the user query and prepares a fine output which a normal user would expect to see, right? Apart from that, it has no other role to play, and you can also send some additional prompts which will help you refine the kind of output that you're looking for. So this is the high level architecture of a retrieval augmented generation or RAG application.